Hey, what is going on guys? It's Abhi here, and today we're back with another math video. So I know it's been a while since I've done a math video, but now I'm back and we can do more this summer because I have no work to do, so we can get maybe 1 or 2 out a week. So we're going to take a break from ACT and move on to an interesting concept in math called calculus. So in any calculus class, in the very beginning, you're going to learn about something called a limit. And today I'm going to give you an introduction on what is a limit. So let's get started. Alright, so you're probably wondering, what is a limit? Well, a limit is defined as the y value you approach in a function as you approach a certain x value from both sides, left and right. So that might seem very complicated, but let me show you in a graph. Maybe that'll help better your understanding. Okay, so let's say we have the graph f of x is equal to 2x. And let's say this is x equals 2, and the point up here, that will make it x equals, that will be y equals 4. Okay, so since a limit is defined as the y value you approach as you approach a certain x value in a function from both sides, right and left, let's try that out here. Okay, so as you approach x equals 2 from the right side, like this, you approach a certain y value. And as you approach x equals 2 from the left side, like this, you approach the same y value. And that y value happens to be 4. So in a one-piece function, in order to find a limit at a certain x value, all you need to do is take that x value and plug it into the function. So let's look at another example. Alright, let's say we have the graph g of x is equal to x squared. If we say that this point is 3, let's say, then that makes this point 9. Y would equal 9 at x equals 3. Okay, so if we take the limit as x approaches 3, then if we look from the right side of the graph and approach 3, we can see that it approaches the value 9. And the same thing happens when we approach it from the left side of the graph. They both approach 9. So therefore, the limit as x approaches 3 in g of x, this is the notation right here, is equal to 9. So let's erase this and let's talk about the notation of a limit. To write the notation for a limit, you first write LIM, which stands for limit. And then you put a variable, and you have that variable approach a certain number. So in the last example, we had x approach 3. And you have that variable approach a number in a certain function. And in the last example, we used g of x. So as x approaches 3, the limit would be what y approaches. So in that last example, y was approaching 9. So in a single piece function, let's write that down, in a single piece function, to get the limit, if you plug in the x value into the function. Alright, so now let's talk about what defines a limit. Okay, so if we take a limit, right, let's say this is y equals 2x again from the first example. And I'm just going to say, let's just say that's plus 1. So this is 1. Okay, so if we take the limit at this point right here, we're taking what it approaches from the right side and what it approaches from the left side. So in limit notation, this is how we would write that. Let's use the last example where we used as x approached 3 in x squared, or g of x. Okay, so as x approaches 3 in the graph g of x. If we wanted to say the limit as x approached 3 from the left side, we would put a minus sign in the exponent spot of the 3. And if we wanted to say right side, we would put the plus sign in the exponent spot of the 3. So now, when this limit right here is equal to this limit, then we can say that the limit as x approaches 3 in g of x exists. And this can only be true if this equals this. Alright, so now let's look at another example where we don't have a single piece function. Let's say we have a function that looks like this. So let's say this is x equals 2, and we're not going to put any equations right now. So let's say this is what we have. Let me just erase and redraw this real quick. So let's say we have a hollowed circle right there, signifying a discontinuity, and a solid circle right there. When we take the limit as x approaches 2 from the left side, let's call this function h of x. If we take the limit from the left side of h of x, let's say this is 4 and let's say this is 6, we can see that as we approach 2 from the left, we're getting closer and closer to 4, so the limit from the left is 4. However, when we approach x equals 2 from the right, we're getting closer and closer to 6. So the limit as x approaches 2 from the right of h of x is equal to 6. Now, this might cause a problem because the limit as x approaches 2 from the right of h of x does not equal the limit as h approaches 2 from the left. Therefore, the limit, so this is therefore, the 3 dots is therefore the limit as x approaches 2 of h of x does not exist. Okay. Now let's talk about one more type of discontinuity where the limit does exist. Let's say we had a function like this. And let's say at x equals 2, let's say this is 4, there is a hollow circle right there. And there is a solid circle right here at 1. Now if we take the limit of this function, let's call it j of x. If we take the limit of j of x as x approaches 2, we can see that as we approach from the right, it is approaching 4. And as we approach from the left, it is approaching 4. However, there is no point at 4. The point is at y equals 1. This does not mean that the limit does not exist. It just means that there is no point that exists at x equals 2. However, the limit exists at x equals 2. So this is called a removable discontinuity. Alright, so now when we look at this function, we can say that there is no point that exists at x equals 2, but we do say that the limit does exist as x approaches 2 in j of x. So this exists, however the point at x equals 2 does not exist. And that's the basics of limits. We're going to go more in depth in the next video, but for now this is all you need to know for the basic limit questions. Next time we're going to go over the rules as x approaches infinity and negative infinity. Alright, that's going to wrap it up for today, guys. I hope you enjoyed. If you did, make sure you subscribe for future videos and like this video and share it with all your friends.